Hi everyone, I hope you're okay. In this video, guys, I'll be doing question 3 from the November 2023 Physical Science Paper 1. This will be a lengthy video because I will answer this question whereby firstly I take up as positive and secondly I take down as positive for those who prefer to take down as positive. Né? Okay, let's just get right into it. Please don't forget to subscribe, like, and share the video, guys, to help us grow the channel. A ball of mass 0.5 kg is thrown vertically upwards from the top of the edge of the building, which is 15.3 meters high. The ball reaches a maximum height of 5.89 meters at the top of the building. The ball strikes the ground and bounces vertically upwards, reaching a maximum height of P, okay, as shown in the diagram below. The first question, okay, we are then told to ignore the effects of air friction. Okay, the first question says that define the term free fall. Free fall is a motion of an object which is under the influence of gravitational force only. Okay. Second question, we are being asked to use the equations of motion to calculate the speed at which the ball was projected upwards. Okay. Whenever you illustrate this thing graphically, it will be like this. You will have your starting point there, and then your ball will reach maximum height, and then when it comes here, that's where the ball passes the same point of projection. Then it will go to the ground. It will go to the ground like this, and then stay there a little bit, and then move upwards at point P. Right, together. So whenever they say to you draw a displacement time graph, this will be a displacement time graph. You are done. Okay, by just tracking the movement of your object. Né? Let's say this is point A. The point of projection is point A. Maximum height is point B. Whenever the ball passes the same point of projection, let's call it point C. And then whenever it reaches the ground, let's call it point D. When it leaves the ground to the maximum height, let's call that point E. And then point P is at the maximum height, right? We are asked to use the equations of motion to calculate the speed of the ball, the speed at which the ball was projected. Nah? I do know information from A to B. Remember that B is at maximum height. B is right there. Nah? A to B. If ever I'm taking upwards as positive, please state as well, guys, on your answer sheet that you have taken up as positive. Nah? Okay, I don't know the initial velocity at which my ball was projected at, and also I know that the final velocity of my ball will be 0 meters per second. The velocity of an object at maximum height is always 0 meters per second, right? The displacement, since the ball it has been displaced upwards, it simply means that the displacement is positive 5.89 meters. Together, and then gravity. I don't care whether my ball is moving up or down. If I've chosen up as positive, that means gravity will be negative. Why? Because gravity is a conservative force and it always acts vertically downwards. It doesn't depend on the path taken by the object. If I said up is positive, my gravity will be always negative. Okay, now they want me to find the initial velocity of the ball, right? I can simply use the second equation, which simply says v squared is equal to vi squared plus 2g delta y. I know that vi squared is 0 meters per second. I don't know the initial velocity. This is negative 9.8 and I have positive 5.89. All together. Whenever I take this to the other side, I'll have v squared equal to negative 2 multiplied by negative 9.8 multiplied by 5.89, and then therefore I'll take the square root. The square root of negative 2 multiplied by negative 9.8 multiplied by 5.89. I'll simply get actually this thing is on scientific notation. Let me change it. Excuse me about that, guys. The square root of negative 2 multiplied by negative 9.8, 5.89. I'll simply get 10.74 meters per second. They said they wanted the speed, né? And since they want the speed, I don't have to worry about my direction. So because speed is a scalar quantity, you can only give the magnitude. So speed is simply 10.74 meters per second. Okay, and then now we are told that after the collision with the ground, the ball leaves the ground at a speed of 11.92 meters per second. Okay, they're telling us that the speed of the ball at position E is positive 11.92 excuse me, meters per second squared. They want us to calculate the amount of energy lost by the ball during the collision. So if you can calculate the velocity of the ball at point D and then find the kinetic energy at D and the kinetic energy at E, then subtract the two, we will be able to calculate the energy lost. Are you together? How can we do that? Let me erase here. For me to find the kinetic energy of the ball at position D, I need to find the speed of the ball at position D, right? I can take information from A to D or B to D, right? But let me just take my information from B to D, just to avoid using the values that I calculated myself. Now, the information from B to D is the information from maximum height to the ground. Now, the initial velocity, the velocity at position B, I know is 0 meters per second. The final velocity, it's what I'm looking for, the velocity of the ball at position D. The displacement, I just need to sum these two up. Whenever I say 5.89 plus 15.3, I simply get 21.19. But remember that, guys, displacement is a vector quantity. So displacement, you must assign your direction. So since the ball will be displaced downwards from B to D, it simply means that I'll have a negative displacement like this. Are you together? And then gravity, I don't care whether my ball is going up or down. Since I did declare that upwards is positive, it simply means that I'll have negative 9.8 meters per second squared. Then for me to find the velocity of the ball at position D, I'll simply use the second equation again. It's Vf squared is equal to Vi squared plus 2G delta Y. I want to find my final velocity. I know that the initial velocity is 0. gravity is negative 9.8, and then the displacement is negative 29.19. Therefore the velocity let me calculate. I'll just put everything under the square root. So I'll simply have 20.40 meters per second. But remember that, guys, whenever you put everything under a square root, you'll get two sets of answers. Your right hand side should say plus or minus. Since we know that our ball was moving downwards, so the velocity of the ball at position D is negative 20.40 meters per second. Now I can easily calculate the change in kinetic energy for me to find the energy lost. How can I do so? The energy lost is equal to the change in kinetic energy, right? Change in kinetic energy is simply the kinetic energy final minus the kinetic energy initial all together. So this is half mv squared final and half mv squared initial. I can simply take 1 over 2 multiplied by m, then I'll have v squared final minus v squared initial. I'll just substitute. I have 1 over 2. The mass of the ball is 0.5 kg, and then I will have final velocity. It was 11.92. The initial velocity, it was negative 20.40, and then this will give me, let me punch, 1 over 2. The mass is 0.5. I have 11.92 squared minus negative 20.40 squared. This will give me negative 68.52 joules. So for the fact that it is negative, it shows that the energy was lost. So therefore the energy lost is 68.52 joules. That's how you would have gone with answering this question, this question 3.1. So the energy lost is 68.52 joules. Okay, now they want us to find the time taken by the ball to reach point E. The time taken by the ball to reach point E, let me just erase here. Point P. Remember that point P is at maximum height. I can take my information from point E to point P, right? I do know my initial velocity is positive 11.92 meters per second, and my final velocity at point P, the velocity of the ball will be 0 meters per second. Why? Because point P is the maximum height, right? So I'll have 0 meters per second. And then I don't know the time it takes. It's what I'm looking for. Also don't know displacement, but I know that gravity is always negative 9.8 meters per second squared. I can simply use the first equation because I don't have displacement. I must just avoid to use any equation that has a displacement. So I'll simply have VF is equal to Vi plus G delta T. The final velocity is 0. Initial velocity is positive 11.92 plus negative 9.8 multiplied by delta T. Whenever the 11.92 goes to the other side, it will be negative 11.92 is equal to negative 9.8 delta T. I'll divide both sides by negative 9.8. So delta T is equal to 11.92 divided by 9.8. I'll simply get 1.22. So the time it takes the ball to reach point P is 1.22 seconds. 1.22 seconds, right? Okay, now we are told that the velocity time graph of the motion of the ball from the instant it is projected upwards from the top edge of the building until the time t it reaches until the time it reaches point P, right? We have K, L, and T1 minus T2, right? This one is the initial motion of our ball. It's the initial velocity of our ball. So here we have 10.74 meters per second, right? And then K is the velocity at which the ball leaves the ground. Remember that we were given that velocity to be 11.92 meters per second. And then T2 minus T1 is just the time it takes the ball to reach the maximum height from the bottom. Are we together? That's the amount of time we just calculated. We just got to 1.22 seconds. Yeah, that's how guys would have tackled this question, guys. Ne? Yeah, and then now I'm about to answer for those who prefer taking downwards as positive. Downwards as positive, right? And in this case they were biased because this velocity time graph they've taken up as positive. So for those who took down as positive, their L will be just negative 10.74, and then this guy will be negative 11.92. But it's fine. Let's just calculate, guys, and see how you are supposed to approach whenever you take down as positive. Guys, I really hope you can see that vertical projectile motion is so easy. It's so easy, guys. It's the easiest topic. The easiest topic. You only deal with one force. It's unlike Newton. Newton's law, you're dealing with multiple forces. But funny enough, most learners find Newton's laws easy. Okay, now we are taking downwards movement as positive, right? Yes, the illustration is still the same. The definition of free fall is still the same. The motion of an object which is under the influence of gravity and gravity only. And then by using the equations of motion, calculate the speed of the ball, the speed at which the ball was projected, right? I can use information from A to B, right? I don't know my initial velocity, but I do know that the final velocity at point B is 0 meters per second. My ball is displaced 5.89 meters up. Remember that I said down is positive now, which means that this is negative 5.89 together. And then gravity, since I said down is positive, I don't care whether my ball is moving upwards or downwards. That means my G will be positive 9.8 meters per second squared, right? So I can simply use the second equation to calculate the initial velocity. So Vf squared is equal to Vi squared plus 2G delta Y. Vf is 0. I don't know Vi, but I do know that here I have 2 multiplied by 9.8 multiplied by negative 5.89, right? Whenever I take this number to the other side, it will change the sign, right? I'll have Vi squared is equal to negative 2 times 9.8 multiplied by negative 5.89. Then just put everything under the square root. You'll simply get 10.74 meters per second, right? Since they said they wanted speed, don't have to worry about the direction. Just know that your speed is just 10.74 meters per second. Okay, and then now we are told that after the collision with the ground, the ball leaves the ground at a speed of 11.92. We must calculate the amount of kinetic energy lost by the ball during the collision with the ground. For us to do that, we must obviously find the velocity at point D, right? We can simply use the information from point B to D. Excuse me. You can simply use the information from point B to D, B to D. I know that the initial velocity, whenever my ball is at maximum height, the initial velocity is 0 meters per second, right? I don't know the final velocity is what I'm looking for, because for me to find the change in kinetic energy, or the kinetic energy lost rather, I need to know the velocity of the ball before the collision, because I'm given the velocity of the ball after collision. My gravity is positive 9.8. Why? I've declared every downwards movement is positive. Gravity is always acting vertically downwards. And then displacement, I'll take the sum of these. What do I get? 5.89 plus 15.3. I'll simply get 21.19. Remember that the ball, whenever it moves from maximum height to the ground, our ball is being displaced vertically downwards. So which simply means that our displacement will be positive. Right, together. So for us to find the velocity or the speed of the ball at point D, all we need to do is to use the second equation and say Vf squared is equal to Vi squared plus 2G delta Y. Now I'm looking for Vf squared. I know Vi squared is 0. I have 2. G is positive 9.8. Delta Y is positive 21.19. Therefore, for me to find Vf squared, I just need to put everything under a square root. Yes, I still get 20. I still get 20.38, but I think I wrote it as 20.40 meters per second, right? 20.4. Okay. And then now I do know the kinetic, the velocity of the ball at position D. I can simply find the change in kinetic energy. You can say that the kinetic energy at D, which is the kinetic energy initial, acidic kinetic energy initial is equal to half mv squared, right? So it's half multiplied by 0.5 multiplied by 20.4 squared. 1/2 multiplied by 0.5 multiplied by 20.4 squared. I'll get 104.04 joules, né? And then EK final, it's half mv squared. 1/2 0.5 multiplied by 11.92 all squared. I get 35.52 joules. Then whenever I subtract the two, let me not round off. .5216 joules, né? And then the change, or simply say energy loss, simply EK final minus EK initial, which is 35.5216 minus 104.04. You still get 68.52 joules. Negative 68.52 joules. Are you together? And then now they want us to find the time for the ball, the time taken for the ball to reach point P. We can simply take information from point E to point P rather. How can we do that? I know that E to P, the initial velocity, yes, I was given the initial velocity to be 11.9 whenever it moves from the ground to go and reach maximum height, né? But since my object is moving, but since this is an upwards velocity, right? So that means it would be negative 11.92. Remember that now I've declared that downwards movement is positive. Are we together? And then the final velocity is simply 0 meters per second. I don't know the displacement, don't know time, but I do know that gravity is always 9.8 meters per second squared. For me to find the time it takes for the ball to reach point P, I must refrain from using any equation that has a displacement, because I do not know the displacement of the object. But I do know an equation that does not have displacement. I'll simply use equation 1. Equation 1, which states that Vf is equal to Vi plus G delta T, right? Vf is 0, Vi is negative 11.92 plus positive 9.8 multiplied by delta T. Whenever I take the negative 11.92 to the other side, it will be positive. So I'll have positive 11.92. This is equal to 9.8 delta T. Divide both sides by 9.8. And then I'll find that delta T will be 1.22 seconds as well. Are we together? Delta T is simply 1.22 seconds. Okay, to answer the following, they wanted K, but they were biased here, guys, because for the velocity time graph, they've taken down upwards movement is positive. How do I know that? because the gradient of my graph is negative. The gradient of my graph is negative, and there's only one physical quantity that is represented by the gradient, and that physical quantity is the gravitational acceleration. Are we together? So L is the initial velocity of the ball. The speed of the ball is 10.74. K is the velocity at which the ball leaves the round. We're given that velocity. And then T2 minus T1 is the time it takes for the ball to reach maximum height. Remember that when the ball, whenever your graph cuts the x-axis, it simply means that your object which was projected is reaching or has reached maximum height. I really hope that, guys, the video was helpful and you learned something in here, né? Please, guys, subscribe, like, and share as much as we can so that you can reach many students as possible. Thank you very much.